In this problem, we're talking about a poster. We're told that we have some top and bottom margins that are 8 centimeters each, and some side margins that are 4 centimeters each. The area of the printed material is fixed at 2,400 square centimeters. Find the dimensions of the poster with the smallest area. Now, don't get confused about the area stuff here. This 2,400 square centimeters, that's set. I can't minimize that. And that's the printed area. That's on the inside of the poster, inside the margins. What we're trying to do is have the smallest area of the overall poster, including the margins. In this type of case, I think I'm really going to have to draw a picture of the situation here. So I've got a poster. Okay. And I've got some margins, 8 centimeters on the top and bottom, 4 centimeters on the side. So that means I've got some smaller rectangle inside the bigger rectangle here. Okay, let me do that again. Well, not much better. All right, doesn't matter much. So the top and bottom margins are 8 centimeters. So that means this distance is 8 and this distance is 8. Whereas this distance is 4 and this distance is 4. Right, those are my margins. So I've got 8 on the top and bottom and 4 on each side. If I'm going to be talking about the overall dimensions, I need to know what the dimensions of that inside rectangle are. Those aren't given. I could use some variables. I could call that distance x and that distance y. So if I want to look at the overall poster then, I've got an overall length which is up and down, but that length then is this y distance on the middle and then 8 on the bottom and 8 on the top. So that overall length would be y plus 16, whereas my overall width then, that would be going across, that's x across on the inside and then 4 on the left and right. So that's going to be x plus 8. And I'm trying to minimize my total area Q. That's going to be length times width. So that's going to be y plus 16 times x plus 8. So that's going to be x times y plus 8y plus 16x plus 128. The problem, of course, is I have a couple variables here. If I'm trying to minimize q, that I'm going to have to find critical numbers, so I'm going to take q prime, the derivative. But I've got a couple variables here, so I need to try to express these variables in another way. And what I can do is use that information about that inner rectangle. That printed area has to be 2,400 square centimeters. And that's that area right here in the middle. So that area would be x times y is going to have to be 2,400. So I can solve this for y easily if I just divide both sides by x. So I would get y equals 2,400 over x. And now I can substitute this information into this equation. One thing, since this starts with x times y, I sort of have a shortcut here. I've written down x times y is 2,400. So I can just make that substitution. So my function q now, x times y is just 2,400. 8 times y, well that would be 2,400 over x plus 16x plus 128. I'll put the constants together and I'll rewrite this fraction with the x as a negative exponent. So I'm going to get q equals 2,400 plus 128. I'll get 2,528. 8 times 2,400 is 19,200. We'll get x to the negative 1 plus 16x. Okay, so that's my function q, and that's sort of my setup of the problem here. What I'm trying to do then, I'm trying to minimize this value q. So 2,528 plus 19,200, x to the negative 1, plus 16x. To minimize this function, I'm going to want to take the derivative. The derivative of a constant is 0. I bring down this -1, so that's going to give me negative 19,200x. I subtract 1. -1 minus 1 is -2, and the derivative of 16x is just 16. I'll rewrite this as a negative x, this negative exponent as a fraction. So I get over x squared. I'm going to write this 16 over 1 so that I can convert to a common denominator. I'll multiply top and bottom by x squared. So what I'm going to get then in the top, I'm going to get 16x squared minus 19,200, and I just get an x squared in the bottom. To find critical numbers, I want to look at this overall derivative and find where it's either equal to 0 or undefined. So q prime is equal to 0 or q prime is undefined. Q prime equal to 0, well, this is a fraction. The only way a fraction can be equal to 0 is if the top, the numerator, is 0. So 16x squared minus 19,200 equals 0. That would tell me 16x squared equals 19,200. I'm going to divide by 16. And if I do that, I get x squared equals 1,200. So if I take the square root of both sides, I get plus or minus the square root of 1,200. Let's see, 400 goes into 1,200, so that would be 400 times 3. So x would be plus or minus 20 times the square root of 3. But of course, x here is a physical dimension, so the negative answer doesn't really make any sense. So we'll just get 20 times the square root of 3, which is approximately 34.64 centimeters. Now, if q prime is undefined, that means the denominator has to be 0, but that would set x squared equal to 0, which would mean x has to be 0, and that just doesn't make any sense in this underlying problem. So I don't really have to consider that. What I've got here, the critical number that I'm looking at, is this 20 times the square root of 3. What I sort of want to look at here is this really a minimum. To analyze that, I can look at the derivative a little bit on either side of this value here. So I can take q prime of 34. So that's going to be, when I look at q prime, that's up here. So it's going to be 16 times 34 squared minus 19,200 all over 34 squared. And if I do that, I get about, it doesn't really matter what I get, just the sign really, but I get about negative 0.6. Do that on a calculator. If I look then a little bit bigger than 34.64, maybe that's 35. We just do the same thing. We plug in 35. Do that on the calculator, and this time we get positive 0.3. So this is showing me that at 34 the function is decreasing, at 35 the function is increasing. And this point at the bottom then must be this 20 times the square root of 3. So it really is a minimum. Now it says find the dimensions of the poster with the smallest area. We've found x. To find the dimensions of the poster, I need length and width. So the length is y plus 16. To find y, Well, y is 2400 over x. So we would get 2400 divided by 20 times the square root of 3. So that's about 69.28. And my width is x plus 8. So that's 20 square root of 3 plus 8, which is going to be about 42.64. So we've got 69.28 centimeters by 42.64 centimeters.